Right, last day. Start machine. McDev, the head of the development team, sends an alarming email stating that they're unable to update the Best Festival Company's external web app. Without the update, no one can view the Best Company's plan. The dev team has been using the CI/CD server to automatically push updates to the server, but the CI/CD has been compromised. Can you help them get their server back? So, understanding CI/CD, overview of risk associated, having a basic understanding of CI/CD exploitation vectors. So, CI/CD are two terms that will come up often when talking about software development and DevOps. Definitions are pretty straightforward. CI, or continuous integration, is the process at which software source code is kept in a central repository such as GitHub. All changes are stored in the central repository and avoid ending up with different versions of the same code. CD, continuous delivery, is the following, sometimes integral step of the continuous integration model, where code is automatically deployed to the test pre-production and production environments. CD is sometimes used as an acronym for continuous deployment. If you feel like the terms above don't seem to have clear limits, you're right. CI/CD and other parts of CD are all part of DevOps best practices that aim to make code delivery faster and more reliable. CI/CD should be considered as a set of practices that are put in place to enable development teams to make changes, test their code, and deploy the application more reliably. We should think of CI/CD as a continuous process or loop that includes steps of the software development process. Risk associated with CI/CD. The CI/CD integration approach seems to be an effective way to mitigate risks that may result from manually aggregating changes made to code, manually testing them, manually deploying them, and updating versions of the application. However, some risks associated with CI/CD process should be taken into consideration when dealing with such an integration. As a pen tester, one of our goals would be to uncover weaknesses in the automation process. These can vary from file permissions to configuration errors made when installing any CI/CD automation software. DevOps teams typically use software such as Jenkins, GitLab, Bamboo, AWS Code Pipeline to automate CI/CD steps summarized above. Major risks related to the CI/CD integration are mentioned below. So, access security. The increasing number of integration points can make access management difficult. Any component integrated with a process may need partial or full access to another component. In this case, allowing too much access can also open a path for malicious activity. Permissions. Components are connected to each other and perform tasks with their user accounts. Similar to access security, permissions should be checked. Keys and secrets. Many integrations are done using keys, API keys, ID keys, etc., or secrets. These should be secured, otherwise anyone can potentially access resources using the authentication mechanism. User security. User accounts are another successful attack vector often used by cybercriminals. Any user who has access to the source code repository could include a malicious component in the codebase and could be included in the deployed application. Default configuration. Some platforms are known to have default credentials and vulnerabilities. If the default credentials are not changed and in use within the CI/CD process, this can result in a complete compromise of the infrastructure. What is this song?
Alright, we get in, we blow up the Mako reactor, and then we out. What actually is...
The Grinch has put his own version of a CI/CD pipeline in place. He's used bash scripts and scheduled jobs to automate the process. Visiting in the browser, so let's fire that up. Uh, 10.10.77.114. Waiting for the loot somewhere else, but this works. So if we visit from the browser, we show the Grinch is waiting for loot, but not here. At this stage, we can run DB scan to discover the admin page, which looks more promising. So let's 77.14114. So let's run DB. We've already been told it's going to run admin, so let's do that. This page will update regularly and show the content of the loot folder. Looking at the source code, we see something interesting. So is this an iframe? Yes. Okay. There's an iframe referring to ls HTML. This page seems suspiciously close to the output run the ls command. Connect to the target machine using in-browser access or via SSH with credentials below. Well, let's do SSH. Why not? SSH. Look. Skiddy at 10.10.77.114. Password is password 1. It's gonna work. There we go. Bit slow, aren't they, these machines today? It's just kicked me. Oh, no, it hasn't. There we go, I've got a login. So if we navigate to cd/home, the Grinch scripts. We'll show most of the scripts in the folder are not accessible by the McSkiddy user. Yeah, so we don't have access. The content of loot shell gives us a clear understanding of the ls HTML. Okay, so it's just doing bin bash ls home Grinch loot straight into there. Change the code in the file to print the contents of the etc shadow file. Okay, so we got access to write to that. Yeah. So then if we refresh, it should load it up. Oh. No, not found. What are you on about? Ah, there we go. It did do it. It's just got to take a little while. Right, so we can read shadow. This is conclusive proof that permission misconfiguration not only creates a threat for the CI process, but can also be used to escalate privileges. If you're interested in learning more about privilege escalation, you can view the realm. This misconfiguration can be leveraged to read the contents of Grinch's other scripts. Let's have a look at check shell, using the vulnerability we have used to read shadow. Okay. So we just keep editing it. What one do they want? Check shell. It's going to ask me for that later on. Let's just copy it. Right, well that didn't work. Do we have to include the root? Actually, that might be it. To the group scripts. Just gotta wait for the CI/CD. Come on. Okay. Secret password reminder script. Curl localhost. Check.txt. If grep remind me txt. Then echo elves fast. Elves are fast. Okay. The script checks for the existence of remindme.txt in the loop folder. If it finds the file, it prints the Grinch's password to a HTML file that will appear there. Alternatively, McSkitty could create a file named remindme.txt in the Grinch's loop folder and wait for automation to work its magic. You really need to though, do you? Because it's right there. Okay, so how many pages did Derby scan with its default word list? So glad I kept that running now. So it found 4. How many scripts do you see in the Grinch's script folder? 4. What are the 5 characters using the $6 $G in Pepper's password hash? Again, I'm glad I saved that now to a mousepad. So Pepper. ZUP42. I was kind of expecting you to have to like reverse the hash for a second. What is the content of the flag.txt file on the Grinch user desktop? CD. Home. The Grinch. Let me guess, this is protected and you've got to output it. Yeah, of course. Grinch. cd scripts nano loop shell desktop flag.txt. And sit and wait. Die Hard is the best Christmas movie. Hell yeah. Alright, there we go. So that's the last one. Cool. That brings us up to date. Let's terminate the box. Ready for day 15, which is out tomorrow.